Hello everyone. So today we will solve the problem 2033, which is today's problem of the day. Let's read the problem statement. The problem name is minimum operations to make a uni-value grid. So you are given a 2D integer grid of size m cross n and an integer x. In one operation, you can add x or subtract x from any element in the grid, right? A uni-value is a grid where all elements of it are equal, right? You need to return the minimum number of operations to make the uni-grid value. If it is not possible, you need to return a minus one, right? So before jumping into the solution, I have a code for you. The code says life has no remote. You need to get up and change it all by yourself, right? So get up, do the things which are do the things which are required for you, right? Things won't happen on their own. You need to take changes for it, right? All right. So let's look at what the problem statement means by, right? So you're given a n cross m grid, right? And in that grid, what they're saying, you can add x or subtract x, right? These values can be either added or subtracted, right? Your wish. After doing so, you need to make a uni-value grid, right? I hope the uni-value grid means is clear that every value should be same, right? If it is, let's say x, this not let's not take x. Let's take, if this value is a, this should also be a, and so on and so on. All elements should be a, right? Any single element, every element should coincide to it, right? All right. And if it's not possible, you need to return a minus one, right? Before looking into the test cases, let's look at the time constraints of the problem. So n into m is 10 to the power 5, right? So uh, n into m is 1 in 5. So you need to write a solution which is definitely big of nm log nm, not more than that, right? On that. At a worst case, you can go to this. If you can write a solution which is big of nm, that will also work, right? This is the worst you can write. All right. So let's look at a few test cases, right? 2, 4, 6, 8, right? Okay. So the grid is 2, 4, 6, 8, and x value is 2, right? So the approach is, what if you try to make the elements 4, right? So let's make element 4. See, first we will understand the test cases, then I will go to in depth why everything is working, right? Be patient for 2 minutes. Quickly, let's look in the test cases, right? So if you try to make it 4, first will cost 2 by 4 minus 2, which is 2 by 2, plus this difference is also 2, so 2 by 2, and this difference is 4, so 4 by 2. So this means 1 plus 1, 2 plus 2, 4, right? So if you look at that test case, the answer is 4, right? 1, 5, 2, 3, and x is 1, right? 1, 5, 2, 3. And if you try to make the elements, let's say 2, right? Then the cost will be 1, x is 1, right? So 2 minus 1 is 1, 1 by 1. Then 5 minus 2 is 3, so 3 by 1. I'm doing abstract, right? The difference is abstract. I can either add it or subtract it, right? So instead of adding, what I'm doing is I'm subtracting from 5, right? So 5, I'm doing 5 minus 1 minus 1 minus 1, right? So which becomes 3, as you can see, right? I think I missed that part, so really sorry for this, right? Okay, so 3, what I will do, I will do 3 minus 1, right? Ultimately, what is happening behind the scene is you are doing abstract value of, let's say this is nums of I, for 1 second, call it that, and let's say this is a value, right? Which is a value from which, the value which you are trying to create, right? So this is the definite formula which you will get, right? Which is nums of I was 3, 3 minus 2, which is 1. And if you look, 3 can be made 2 in just one operation using the value of x equal to 1, and the way is 3 minus 1, right? So you don't care what is happening behind the scenes, you are just focusing on the abstract difference of them, right? Like 5 took 3 steps. How did it do? 5 minus whatever the value is, right? Value was 1, and you're dividing it by x, because let's say the value was 5 and you wanted to make it 1 and x was, let's say, 2, right? So how many steps you will take? You will take abstract of nums of I minus val divided by x, right? And how is it happen? 5 minus 2 minus 2, right? And if you put the values on here, 5 minus val was 1 divided by 2, which is equal to 4 by 2, which is 2, right? So I hope the behind the scenes, right, how abstract is actually working, you are understanding it, right? All right. So where were we? I forgot, right? 1, 5, 2, 3, and we saw that we try to make every elements of this equal to 2, and this cost 1 plus this cost 3 plus this cost 1, right, which is 5, right? And if you look at the answer, it is 5 as well, right? You can make every element to 3 as well, still the cost will be same. And now how will the cost be same? I will make that as well. Let's look at the last test case, 1 2 3 4, and 1 2 3 4, and x value is 2, right? So you can understand one thing from this place is that if a value is if every value in my grid modulo x is not same, right, is not same, then I cannot make every element same, right? And this thing should be a bit obvious to you, right? Let's say, yeah, so I was talking about what if the numbers we had, we need to convert that number to any other number, let's say x1, right? So the first thought which I am implementing is every number's modulo should be same. Every number's modulo x should be same. Now, why am I saying that? Let's try to understand. Let's say I had a number 3, right? And x was equal to, let's say, 2, right? So this number can travel to 5, 7, 9, 11, 13, 15, 17, dot dot dot, so on and so forth, right? So what are you getting here? The thing which you are getting here is if the number don't have a similar modulo x, then you won't be able to make it no matter how many times you subtract or add to it, right? Let's say if I wanted to make a 10, there is no way that I can make a 10 from this, right? Even though I can make a 17, 13, 15 and everything, but 10 can't be made, right? And how is that seen? 10 modulo 2 is 0, and 11, or rather 3 modulo 2 was 1, right? So see, these two numbers are different. This alone should give you a hint that if two numbers are not, let's say, are different, modulo x are different, then you can't make it, right, in any possible way, right? Because there's a fixed pattern in which the numbers will be rotating by adding or subtracting a x, right? 3 can, let's say if x was 4, so the pattern is 7, 11, 15, 19. If I say you to make a 16 or a 17 or a 18, you can't make it, right? Because if you get to 15, after that you can add a 4 to get 19, or you can get a plus minus 4 to get 11. So the cycle is something like plus 4 only, right? So 16 in, on the other hand, if you had a 16 and if you wanted to add, subtract a 4 or add a 4, then it becomes 12 and 20, and there is no other way that you can reach to the point 15, right? So I hope this point is clear to you. So the first step is see if every value has same modulo, right? If it doesn't, then you simply, if not equal to, not equal, then what you will do, you will simply return a -1, right? I hope this thing is clear why modulo of x every value should be same, right? Now if the modulo is same, right, let's say modulo was same, then what is the minimum number of operations is what you need to find, right? Min operations. Now how will you find a min operation? See, whenever you had an elements, let's say you had 2 4 6 8, right? Then the first thing, and x was 2, right? X was 2. So the first thing which you need to do is check for a median, right? Now why and how did median come into play, right? Let's say you wanted every element to become 2, right? So this number could be, let's say, very big, it could be 100, right? And now when you try to make these elements 2 2, right, the cost will be more. How? Let's just find the difference to understand what is the difference if I wanted every element to make to 2, right? So difference will be 100 minus 2 plus 6 minus 2 plus 4 minus 2, right? So it will be 98 plus 4 plus 2, which is 100 plus 4, 104, right? Now let's try to make every element to 6, right? So difference will be 100 minus 6 plus 6 minus 6 0, 4 minus 6 minus 4 plus 6 minus 2, right? I'm doing the abstract difference. Why I'm doing the abstract difference? I hope that is clear to you, right? Now the difference will be very clear to you. Wait a second. Yeah, yeah. So difference will be 94 plus 2 plus 4, which is 90, 100, right? See, the difference came down by a bit. Now, is there any mathematical proof to what I'm saying? Because you can't be going everywhere and say that, okay, I will do this, right? No, you won't be doing that, right? So let's say summation of I equal to 1 to n, right? I will explain whatever I'm writing, right? Let's say you are starting from index 1, you are going to index n, and let's call it a median, right? And you want to subtract a value nums of I, let's say, right? So in order for this to be balanced, right, median is the element which we are choosing. Why is median working? That is also I will explain that as well, right? So if median is, if the median is in the middle, right, then the difference on the left side is also balanced, and the difference on the right side is also balanced for this condition, right? If you wouldn't have taken this, what would have happened is you would have get up this value till this point, again this value to this point, this value to this point, and thereby making the things large for you, right? There might be a case where median and this might give same results, but median in almost most of the cases, right, will give you a better answer than taking any extreme low or high values, right? And why is that so? Because this median lies in the middle of the left and right elements, so there is no disbalance for you to create, right? Whereas if you take the elements on the left, then the elements which are on the right will create a heavy element for you, and thereby you will have to use more number of operations to reach there, right? Now we are given a grid of 2D, right? How will we supposed to find median of this, right? So what we can do is we can simply convert this 2D grid into a flat vector, right? What is a flat vector? This is just a fancy term. What you can do, you can simply traverse from all the elements and put it in a simple vector, right? Now this vector will have all the elements which were there, right? After getting all the elements, what you can do, you need to find the median. See, these are the conditions which are happening only if we had the opportunity to create it. If we already returned the -1, means the modulo x was, every element modulo x was not equal, then no need to come here. You simply return the -1, go back home, right? Else you need to find the median. Now how will you find the median? To find the median, you will simply put all the elements in this sort array and then sort it, right? These are the steps for finding the median. And then median is nothing but the length of the array, length of array divided by 2, whatever the length comes, right? So you will stand in the middle, either this element or this element, no matter what, you can take any of them, the answer will be same, right? After this, what you can do, you can simply find the difference, that like how we did, the difference was abstract of nums of I minus median divided by x. This will give you a additional value that you need to add, right? And this simply adds in our answer, right? So this was the whole approach. I hope the problem statement and everything was clear to you. Let's quickly look at the code, right? So the first things first, what we did, we first created a vector flat, right? And the remainder was the first element's remainder, whatever the remainder was, right? We will do a dry run on this as well so that you can understand, or rather this one, whichever I will do on this one, you can do on the other one as well, right? So what we are doing, we're simply traversing, and the remainder initially will be x was 2, right? So let's quickly look at that as well. 2 4 6 8, right? X is equal to 2. What you will do, we will find the remainder. So 2 modulo 2 is 0, 4 modulo 2 is 0, 6 modulo 2 is 0, 8 modulo 2 is 0. So every element gave you a remainder 0, right? If at any point you found that remainder was not same as initial value, right, initial remainder, then you will simply say return a -1. Else what we are doing, we are simply pushing in our flat vector. Now what does this flat vector do? This simply sorts the element, right? We find the middle element. How do we find the median? We simply do flat of size by 2, right? And after that what you are doing is simply traversing on the flat array, right? And difference is equal to abstract of flat of I minus median, right, by x, as I said, right? Because you found the median, let's say median was 4, right? Now what you need to do, make every elements 4. 6 goes to 4, 8 goes to 4, and we have what we are doing, the simple formula was simple: abstract of whatever the flat value of I is minus median divided by x, because that many operations you will require, right? 4 will take 4. If you want to make 4 to 8, the difference is 8 minus 4 by 2, which is 2. You need two operations. In one operation you go to 6, another operation you go to 8, and that's it, right? And you simply return the answer. So if you look at the time complexity of this problem, it is big of n into m, because you first created the vector, and after that you sorted it as well, so it becomes nm log nm, right? And the space complexity is also big of n into n, right? And that's it for the problem. If you submit this gets accepted. So I hope the problem statement is clear to you. If you have any doubts, do ask in the comments. I will be happy to help you out. And that's it. Meet you in the next one. Thanks for watching.